We are going to look at how quadratics are in the real world. So, anytime you're playing sports and dealing with a ball, you are dealing with quadratic function. So, think about someone who throws a football. It is going to climb and then it's going to fall down, and the receiver is going to catch it. Think about basketball. Whenever you throw the basketball to hit the hoop, to go in the hoop, it's going to go up and hopefully land inside the basket. Think about golf. You are going to hit it and it's going to fly up and then it's going to come back down. So the way that it makes a quadratic is that you give it some force to throw it or kick it or hit it, and then gravity has an effect on it that causes it to come back down. So if we look at this example, we are only going to look at quadrant 1. So this would be quadrant 1. It's the positive quadrant. Because in the real world, we are not going to be looking at negatives. So think about if you're kicking something, it's not going to start at a negative distance or negative time. It's going to start wherever the ball is located at the beginning. And then wherever it stops, it's going to be right here. So let's think about this example where someone is throwing a ball. This would be considered time. So it's your x-axis, but in this situation, it's time. Could be different things, but let's say it's time. So this is how long the ball was in the air. And then this can represent the height. This is your y-axis, so it can represent the height. So we have time and height, x and y. So each one of these things represents something. So we're going to start here, 0. Remember, a 0 is your x-intercept, your solution, your root. So here is a -0. This would be before time begins. Can we have a negative time? No. So this 0, we don't worry about it. It's the -0. We aren't going to have negative time. The first point that we're going to care about within this function is right here. This is your y-intercept. This is how high off the ground did the object start. So let's say you are at Top Golf and you are going to putt the golf ball. I guess not putt. You're going to hit the golf ball and it's going to go off. So in this situation, it's not on the ground whenever it begins. It's up high. Or you could be, a basketball. It depends on what these units are. But let's say a basketball, you don't shoot from the ground. You shoot from where your hands are, up close to your shoulders. Anytime it starts down here, that's closer to like kicking a soccer ball. So right here is how high off the ground did the object start? How high did the object start? Then this is your vertex. It's the point that it changes direction. In this case, it is a maximum value. Your vertex is written as an x and a y coordinate. X is when is the object at max height. So let's say it's at 20 feet or whatever it is. The y value of the vertex is how high does the object get. Or you could talk about what is the time that the object hit that maximum height. So questions that you might see are how high is the object after t seconds? So you look here and then find out what the height is. Plot given seconds into graph's equation. And then your +0, when does the object hit the ground? So this would be ground level, when meaning time, how far. Another thing is how long is the object in the air? So that is another question you might be asked. So we're going to look at this first example. Suppose you're tossing an apple to a friend on a third-story balcony. After t seconds, the height of the apple is in feet is given by h equals -16t squared plus 38.4t plus 0.96. So notice this doesn't say y equals, but we're going to go ahead and put y underneath h, because normally we have an equation written as y equals. Then the t's, that means that the t's are x's. So if you were to type this in your calculator, you would definitely need to change this to y's and x's. Desmos, though, you can use h's and t's. Before we put it in the calculator, in Desmos, let's look at our graph here. So this is my x-axis, which let's see, what does x represent? X represents t, and t is seconds. So I'm going to put t seconds as my name for my x-axis. Make sure you leave some space because we're going to put some numbers here. And then our y-axis is h. So let's look at what h stands for. H stands for height of the apple in feet. So I'm going to write height. I'm going to put feet. Height in feet. And I left some room so I can put some numbers here. I need my units. And we have some questions. Number 1. Oh, let's see. Your friend catches the height just as it reaches its highest point. Highest point? That's our vertex. Let's look at number 1. How long does the apple take to reach your friend? So that's going to be time, right? How long in time? And at what height, so this is the question 2, at what height above the ground does it catch it? Height would be feet, right? So we have 2 questions we need to answer. We're going to answer them over here. So let's sketch this graph out. But in order to sketch it, we need to graph it. So go over here. We're going to type in the equation. H equals negative 16t squared plus 38.4 plus 0.96. Oh, I forgot something, didn't I? I forgot to put t there. Oh, there we go. Okay. So I want to be able to see the maximum height. I only care about quadrant 1, but I want to kind of stretch this out a little bit. So let's look and see. Our height starts at 0, and then let's see how high it goes up to 25. So let's count these and see what I can do by units. 1, 2, 3, 4, 5, 6, 7, 7. But this actually goes by 5. So why don't we do that? 5, 10, 15, 20, 25, and 30. Let's see. What is the height? It goes up to 24. Let's look at the bottom. I really don't want it to be like this. I want it to be spread out a little bit. So I'm going to look and see. It goes to 2.4. So I need this to go to 2.5. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that could be 10 if I extend it. So let's do 0.5. I'm going to skip and go 1, skip and go 1.5, skip and go 2, and then this is going to be 2.5. So what I can actually do is I can make this and this match. So look at where my mouse is. It has the wrench. Click that. My x-axis, see how I have x-axis here? I'm going to go from 0 to 2.5. So all I did was look at the range here, so I could kind of spread it out a little bit. And then my y-axis, I'm going to go 0 to 30. There we go. So see how I changed my x and y axis? I don't see the bottom, so I'm going to go ahead and move it so I can see my x-axis. Okay, so I need to put some points on here. So one of my first points is going to be my y-intercept. It's 0.96. So if I look over here, here's 5. So there are 5 little tick marks in here. So let's find out where 1 would be. So 0.96 feet. So it's almost 1 foot. So I'm going to put 0.96 There's a point right there. So 1 foot off the ground is where he throws the apple. So maybe he's like, he kind of bends down, he squats down to toss the apple up to his friend. Remember the whole context of this problem? Okay, let's see, where does it reach its maximum? Oh, it's right here. 1.2 to 24. So 1.2. This would be 1.25 because it's halfway. So 1.2, I would imagine, would be like right here. And then up to 24. So imagine it'd be like right there. So that looks like a good estimate. 1.2 to 24. And let's see, where does it hit the ground? At 2.425. So that would be like right here because it's right before 2.5. So let's kind of make this look like a parabola. Remember, it's symmetrical. Okay. It looks all right. Doesn't have to be perfect. I'm just trying to get this to match this. And the way that I made it look a little better was changing my X and Y axis. And anytime you move this around or like zoom in, zoom out, it's going to change what these values are. But you can always go back and change it. Okay, so let's answer the questions. It says, how long does the apple take to reach your friend? Well, we got to know, where is our friend? So let's look back at the question. Suppose you're tossing an apple to a friend on the 3rd-story balcony. Your friend catches it just as it reaches its highest point. So this is where your friend is going to be. Friend on 3rd story. Or 3rd floor. So how long does it take? So how long is how many seconds? So let's write the coordinate pair for that. That was 1.2, 24. And we got that from Desmos, from the graph. So it says, how long does it take to reach your friend? So X is our seconds. So it was the 1.2 seconds. And then the next question, number 2, is what height above the ground does your friend catch it? So height, here's your friend, 24, and it's feet. We could have done all of this just by looking at Desmos, but I wanted you to see how you could graph it from Desmos. Okay, I want you to answer the questions for number 2. This is question 1. Question 2, mark out the how long was a football in the air, because we don't know that. Because this is height, this is distance. So that's not. So the 3rd one is about how many yards the football. All right, continue to come. So go ahead and answer these questions. Go ahead and look at it and answer those questions. So it says, what is the maximum height of the football? So this is height. Height is h. The maximum height, well, let's look at what the coordinate is for the vertex. This is our max. I'm going to go ahead and write the coordinates. It looks like it's at 30. Say 56. So what is the maximum height that it goes? Looks like it's 56. And what units of measure? We're in yards. Number 2, what's the furthest distance? So how far did it go? So it looks like it stopped here. So that'd be 60 yards. And then number 3, about how many yards did the football continue to climb after traveling 20 yards? So it went out 20 yards. And how many yards did it continue to climb? So let's find out. Where is it at? It's right around here. How many more yards did it go up? How many yards did it continue to climb? So climb means how much did it go up? That's the height. So it was at about 50 and it went to 56. So it went up 6 yards. Go ahead and glue this in.